Hello everyone. In this video, we will discuss the D flip-flop, also known as the delay flip-flop or the data flip-flop. In the previous class, we have studied that a clocked RS flip-flop requires two input signals to drive the flip-flop, which is a disadvantage with many digital circuits. Also, we have seen that when both the input signals become high, it gives an undesirable condition. So, these drawbacks of clocked RS flip-flop are overcome in D flip-flop. A D flip-flop is simply an RS flip-flop with an inverter in the R input. By adding this inverter from the S input to the R input, the number of the inputs to the flip-flop reduces from 2 to 1. Sometimes this flip-flop is also called a gated D latch. The logic diagram, circuit diagram and the symbol for D flip-flop has been shown in the figure 1, 2 and 3 respectively. From the diagram, we see that only a single data bit D is required to drive the flip-flop. When the clock signal is at low level, the data bit D is prevented to reach at output Q until the clock signal becomes high at the next pulse. So, we will now see the working principle of the D type of flip-flop. When the data bit Dn is high, the output Qn plus 1 gets at the high level, and when the data bit Dn is low, the output Qn plus 1 gets at low level. So, a D flip-flop transfers the data bit D to the output Q as it is, and Q remains in the same state until the next pulse of the clock arrives at its input. The truth table for a D type of flip-flop is shown in this figure. From this figure, we find that when the value of Dn is 0, then the value of the output is 0. Similarly, when the value of the input is 1, the value of the output Qn plus 1 is 1. Since the transfer of the data from the input to the output is delayed, so this flip-flop is also named as the delay or the D flip-flop. The D type of flip-flop is either used as a delay device or as a latch to store one bit of binary information. That is, this D type of flip-flop can store either 0 or 1 as the information. Now next we will discuss the edge type of flip-flop, that is the edge triggered D flip-flop. In a D flip-flop, sometimes the presence of some external signals like noise is found on the input side along with the relevant input data. These external signals on the input side of the flip-flop may lead to wrong output if they appear when the clock signal is high. This problem can be overcome up to some extent if the time duration of the pulse is reduced. So, for this purpose, the clock pulse is supplied to a trigger circuit which produces a short duration pulse to make the flip-flop enable. The trigger circuits respond when the clock pulse goes from low to high level, or it responds when the clock pulse goes from high to low level. In the former case, that is, when the trigger circuit responds when the clock pulse goes from low level to high level, then this type of triggering is called positive edge triggering or the leading edge triggering. And the second case, that is, when the trigger circuit responds when the clock pulse goes from high to low level, it is called negative edge triggering or the trailing edge triggering. The symbols for the edge triggered D flip-flop has been shown in the figure 5A and 5B, and the truth table for positive edge triggered D flip-flop has been shown in this table. So here we see that this is the circuit for positive or leading edge triggered D type of flip-flop. This is the D input, this is the output Q and Q bar, this is the clock, this is positive edge triggering, which will respond when the value of the pulse goes from 0 to high. So we have shown an arrow when the pulse is going from 0 to high, so it will work at this edge. So this is the symbol for positive or leading edge triggered D flip-flop. Similarly, if it is negative or trailing edge triggered D flip-flop, then the symbol will be as shown in this figure. Here we will have one bubble. There will be a bubble which indicates that this is negative edge or trailing edge triggered flip-flop, which will work when the value of the clock pulse goes from 1 to 0, that is at this edge, and that is why it is known as negative edge triggered D flip-flop. Now this shows the truth table for positive edge triggered D type of flip-flop. Because this is positive edge triggered D flip-flop, so the symbol for clock has been shown by an upward arrow. That is, this is the positive edge triggered. So the symbol for clock has been shown by an upward arrow. Now when the value of the input D is 1, we will get the output Q as 1. When the value of the data will be 0, we will get the output 0, and the complement of the output will be 0. When the output is 1, that is Q is 1, then the complement will be 0. When the output is 0, the complement will be 1. So when the value of Q is 1, this will get set, that is, it will store a 1. Similarly, when the value of the output is 0, the flip-flop will get reset, that is, it will store a bit 0 as the binary information. In this way, the D flip-flop works when it is positive edge triggered or negative edge triggered. So this is the how the D type of flip-flop works. Hope this is clear to all of you.